Hi, I'm Suha. This is my Teach One for class HAP 823 on the topic benchmarking. In this question, we are asked to create synthetic cases to estimate mortality rate for 80-year-old residents with walking and toileting disabilities, but no other disabilities. This is a screenshot of the data on how it looks on Excel. You can see that there are no headers with the column names. To answer this question, all the next steps will be on SQL. The first step is to create a table called patients with all the column names, and we are giving them values. The value 1 is just for old, male, and for unable to walk and unable to toilet, and for the rest we're giving 0, and this is how the table looks. As we have seen in the previous screenshot, our data did not have any column names, so we are going ahead and giving the column names here, and we are also creating a new value for the age just to get the accurate number based on their visit. The first subdivision of this question asks us to check if there are below 30 cases with the following conditions, that is age is equal to 80, unable to walk and toilet is equal to 1, and rest all the conditions are equal to 0, and we are verifying that there are just 5 cases which shows it's below 30. I've attached a screenshot of the code which is used to calculate the mortality in 6 months. The first we are creating a temporary table called dead, in which we are following the assessment number and dead is equal to 0. And over here below we are binarizing the age column, and then we are going ahead and creating a join with the dead table, and here we have got another temporary table called data2, which we'll be using for the next steps in our analysis. The next step is to calculate the probability of mortality with more than 29 cases, and this is the code that I have used. We are just creating a strata, and later we are going to use this strata to create another table for matches, and this is the code. This is the screenshot of the next steps, wherein we create a temporary table called matches from strata and the table that we used at the very beginning called patients. As our question asks, we are creating both partial matches and excessive matches. So in this temporary table, we are creating 3 matches. One is matches, partial matches, and excessive matches, and this is the code. This is our last and final step. We are close to the answer, and we are asked to create both partial and excessive matches. To create that, we are using Tversky scale. According to Tversky scale, we use 0.8 for excessive matches and 0.2 for partial matches. And over here you can see 2 tables, with the one for most similar strata where a feature missed in patient is more important than a feature in the strata, and the second table is for the most similar strata where a feature missed in patient is less important than a feature in the strata. So we have our similarity index, the probability, and the case numbers here, and this answers our question.